Hello and welcome to Chapter 6 of Statistics 1. In this chapter we're going to be focusing on correlation, and specifically the statistic of correlation coefficient. For this brief screencast, I want to do two things. First, I want to talk briefly about the overall idea of correlation and the statistics of R, which is the correlation coefficient, and what it means and how to interpret it. But I also want to walk you through how to use Excel to help you in finding R with the computational formula from the text. So first things first, let's talk about correlation. Um, the chapter started off by giving examples of taking a look at the relationship between, if you have individuals here, and they use the example of these 5 friends here, of what's the relationship between the number of holiday cards somebody sends versus the number of holiday cards they receive, and is there a relationship between them? And the word correlation, if you notice, it has two parts to it. Co meaning you're comparing two of them, and then relation or relationship. So in general, we're trying to come up with a statistic to determine, number one, what type of relationship is there between the two sets of data? Is it positive or is it negative, or is there no real relationship at all? Positive meaning as the value of one variable increases, does the value of the other variable increase also? Or if it's a negative correlation or negative relationship, does as one value increase, does the other one decrease? Then the other part of it is, or the other measure, is just how strong that relationship is. So you might have two sets of data that both are positively related, meaning as one value goes up, so does the other. But there might be a strength value to it. So the correlation coefficient, represented by the variable R, and I'm going to use this little graphic right here to help you with it, is basically a statistic that has a value from -1 to +1. And I like to use a number line here, or a portion of the number line, to illustrate it. Just like your stereo might have a volume that goes from 0 to 10, or in some cases 11 in some movies, this is a statistic or a measurement that goes from -1 to +1. And there's two main components of it. First off, if you have a relationship that is positive, meaning as one value increases, so does the other, then you're going to end up with a positive value for R. And if it's a negative relationship, meaning as one increases, the other one decreases, you're going to end up with a negative value for R. And if you end up with a value of 0 or very close to 0, then you basically are talking about a relationship that is neither. That there's no relationship between the two of them, and maybe one value can't help you predict the value of the other. But the other component here, besides positive and negative, is how strong or weak that relationship is. So if you picture an R value of positive value in this side of the number line, the further or closer you are to +1, the stronger the relationship is, and the closer you get to 0, the weaker. Likewise, on the negative side of the number line, the closer you are to a -1, the stronger the relationship is as compared to a value that is closer to 0. So the two things you want to take a look at when measuring a relationship are, again, the positive or negative, and just how strong they are. Or in a case where it's getting closer to 0, it's a weak relationship. So hopefully this visual will help you a little bit in comparing the numbers. The second part here is this. In a text, there's a computational formula for R, and I want to walk you through it briefly, both actually the definition formula for it, but also the computational formula. And we're only going to have to do this once in the course, where we'd like you to walk through the actual process of calculating R. But I do want to point out and walk you through how you can let Excel help you with it. And after you do that, for example, homework item 6.7 is the one time you have to calculate R. And then there's one time in chapter 7 we're going to have you walk through that also. After that, you can use either a calculator or Excel to calculate that value for you. But I do think it's valuable for you to walk through it to get a sense of what's going on in determining this value. So, correlation coefficient R is represented by this formula, which is pretty complicated here, but the numerator, you can see, is defined by this formula down here, which is the sum of the products. That's what it's called. And the denominator is the square root of the product of the two sums of the squares of the values. Again, very complicated looking formula, but I want to walk through it step by step. So you follow this red line here. It gives you that one part of the denominator here, which is the sum of the squares of the x values. Basically what's happening is for each x value, in this case here, the x values are here, you are finding the distance or difference of that number from the mean. And then once you find that value, you square it, and then you do that again for each value. Likewise, for the sum of the squares, the y, you take each y value, in this case it's these values. For each one you find the difference from the mean, you square that value, or that difference, and then you add all those up as well. The sums of those give you these values. Alright? Now, the fact that you're squaring them, you're always going to end up with a positive value, which then allows you to take the square root. If you had a negative value under here, you have a problem. But the numerator, if you take a look now, these are comparing pairs of these coordinates. So, for example, if you take a look at this portion of the formula, you're going to take an x value, find its difference from the mean, and then the y value that's associated with that x value, and find its difference from the mean. Which means I'm taking a look at 13 and finding the difference from the mean, which the mean of these values was 7. And I'm taking a look at this value that again is aligned with the 13 and finding its difference from the mean. That's what's going on for each of, in this case, the 5 values. And you're multiplying those differences together and then adding those up. Now, where the positive and negative for R comes into play, if you recall, R is a value that you're going to get either between -1 and +1, is this. And I'll use this scatter plot over here as an example for you. If you take a look at the values below here, and this, for example, is the coordinate of 1, 6, which is represented by John over here. John has sent one card out and received 6. Alright? This value here, both the x-coordinate, which is 1, is less than the mean, which is a negative, and the y-coordinate is less than the y-mean. I'm sorry, I went the wrong way there. So the y-coordinate is less than the y-mean, and the x-coordinate is less than the x-mean. So both values are negative in this portion of the calculation. And if you multiply a negative times a negative, you get a positive. Likewise up here, I'll use this coordinate. This was Doris. Doris sent 13 letters and received 14. So for the number of letters she received, which was 14, it was greater than the average of the group of the y's received. So that's a positive value. And her x-coordinate, which was the number that she sent, was also greater than the x-mean. So you're dealing with a positive times a positive, which also is positive. So if you have a relationship where the as the x values are increasing, so does the y. You can see it, for example, in the table here. As the x's increase, overall, so do the y's. It will also be represented by on a scatter plot of a graph that's going to have a positive trend to it. All right, that will lead us to a positive r value. Now, the opposite of that would be is if we had a situation where they were negative. If you had values up in this area and the trend continued down this region, you're going to end up with a negative correlation coefficient to represent the negative relationship. All right. The textbook walks you through that as well, but I'm hoping that discussion helps a little bit. Now let's take a look at the computational formula for it. And this I would recommend following for item number 6.7 from the text for your homework. What I set up here were tables or columns to represent the different pieces of the computational formula here. And what I did was, if you're following along, if you can kind of get the gist of the text, it first gives you what the formula for is by definition. But these definition formulas are very complicated to follow. What we're going to do instead is use the computational formula, which really doesn't tell you what's going on, but it's a lot easier to manage the numbers. So I'm going to use Excel to come up with each of these highlighted in yellow pieces. So I have the x values and the y values in these coordinates. I have a column which represents x times y. And in order to do that, I want to put the cursor in this cell and hit equals. And then I'm going to select this and click on the 13. Above the 8 is the asterisk. Use that for multiplication. So it's times, and then this value. So this x times this y gives me this value. And I'm going to hit return. And you can see up here where it shows in the formula B4 times C4, which is this value times this value. I want to continue this down this column. So I'm going to click on this bottom right. You can see where the cursor changes. And I'm going to drag it down. So now I've multiplied these going across for each of the 5 pairs. Now I want to square each of the x's. So I'm going to put the cursor in here. I'm going to hit equals. And again, it's x squared, so I go back to 13, which is Doris's x value, and I'm going to square it. So you can either do that times itself, or I'm going to use the caret symbol. So shift 6 and then 2, and that squares that value. Again, I'm going to follow that and drag that down for those values. I'm going to do the same thing for the y. Hit equals. It's the y value. Shift 6 for the caret, squared, and enter. I'm going to drag that down so it applies to those. Now what I need for each of these, and you'll notice here in the formula, all the sigmas, the sum of the x's squared. And here's the sum of the x's squared. Make sure you realize these two are different. Same thing for the y's. And same thing down here for the sum of the x times y. So all of these are highlighted in yellow, can be found by simply going, I want to find the sum of each of these columns. I'm going to change this to sum. I highlighted these columns and I hit enter. And then once I click on that 35, I can then drag it underneath each of these. Now I have the sums that I need. And these values in yellow correspond with these values in yellow for that computational formula. Okay? So take your time, walk through it, but then plug them in appropriately. So for this value here, I get it from here, the 484. The sum of the x's, I can get it from here, 35. The sum of the y's, I can get it here, the 60, and so on. So now that you have all the information there, it's a lot easier to plug in. I highly recommend you using this for item number 6.7 in the text. Thank you.